Hey everyone, welcome back to another video. In our last video, we talked about measures of central tendency and how they can help us find the center of a dataset. In this video, we'll be discussing measures of dispersion and how they can help us find the spread of a dataset. If you haven't already, go ahead and watch our video on measures of central tendency before watching this one so that you can get the most out of it. Let's get right into it. The term measurement of dispersion refers to statistical tools that can be used to describe how spread out or how much the data varies in a dataset. In contrast, measures of central tendency like the mean and the median help us find the center of a dataset. Here are the four main measures of dispersion. The first one is the range. The range is the simplest measure of dispersion and is calculated by subtracting the smallest value from the largest value in a dataset. To illustrate, let S take a look at this dataset, which represents the number of pets owned by students in a school. The largest value is 4, and the smallest value is 0. Subtracting the smallest value from the largest value gives us a range of 4. The range is useful for getting a quick sense of the spread of a dataset, but it is highly sensitive to outliers, which are extreme values that can be quite far away from the other data points. So what exactly are outliers? Outliers are data points that significantly deviate from other values in a dataset. They can be caused by various factors such as measurement errors, data entry mistakes, or they may represent genuine rare occurrences. These data points can have a substantial influence on the outcome of statistical analyses, and it's essential to identify and address them appropriately. There are different ways to identify outliers, including using box plots, scatter plots, or by calculating z-scores. Once identified, they may need to be investigated further to determine if they should be removed from the dataset, or if there are other reasons to retain them. Depending on the context of the analysis and the nature of the outliers, the decision on what to do with them can significantly impact the results and interpretation of the study. The second measure is the interquartile range, or IQR. Unlike the range, which considers all the values in the dataset, the IQR focuses on the middle 50% of the data. To calculate the IQR, we first need to find the first quartile, Q1, and the third quartile, Q3. The first quartile represents the 25th percentile, meaning it is the value below which 25% of the data falls. The third quartile, Q3, represents the 75th percentile. To find the IQR, we subtract Q1 from Q3. In our previous example, the IQR would be 2 because the IQR is not affected by outliers. It is considered a more robust measure of spread than the range. The third measure is the variance. Variance is the average of the squared differences from the mean. It essentially measures how much each value in the dataset deviates from the mean, and then it squares those differences. Squaring the differences ensures that all values contribute positively to the overall measure of dispersion. The variance is useful for understanding how data points are distributed around the average. But it is expressed in squared units, which can make it hard to interpret. For example, if the original data is measured in meters, the variance will be in meters squared. This can make it difficult to compare the variance to the original data or to other measures of dispersion. The fourth measure is the standard deviation. The standard deviation is the square root of the variance. By taking the square root of the variance, we get a measure of dispersion that is expressed in the same units as the original data. This makes it easier to interpret the standard deviation in the context of the data. The standard deviation is widely used because it is easier to interpret than the variance, and it is also easier to work with mathematically. A low standard deviation indicates that the data points are close to the mean, while a high standard deviation indicates greater spread. In summary, measures of dispersion are essential for understanding the variability and distribution of data in a dataset. Different measures provide different perspectives on the spread of the data, and each has its own strengths and limitations. The choice of which measure to use depends on the characteristics of the data and the goals of the analysis. Whether it's assessing the impact of outliers, understanding the distribution of data around the mean, or comparing measures of spread, these tools offer valuable insights into the nature and behavior of data. As always, thank you for watching, and see you next time.